Okay, let's talk about phase shifts. Here is the graph of sine of x. The default normal graph has a period of 2 pi. It goes up first, and then middle, down, back to the middle. Okay. Here's sine of 2x, which is faster, higher frequency. So the period is half as short. It goes from 0 to pi. All right, now let's talk about phase shifts. If you add a number, like whatever number, to it, let's bring the a back to 0. So nothing is happening here in terms of shifting, but the moment you add to a, 2x plus 1, 2x plus 2, which direction will it move if you add? Let's add gradually something to that 2x, and look how it's moving to the left. That's what you've always been taught. It does the opposite, doesn't it? And if we subtract, the a gets more and more negative. You're moving to the right. You can literally see it move to the right. So I think that's something that you understand from working with transformations of functions, that things that happen to the inside have the kind of inverse effect on the graph. Okay, so here's a phase shift. We're adding pi over 3 to 2x on the inside of the function. Okay, so here's 2x. Where would you expect the function to start? Because it starts here, and it goes up, back down, down to the min, and back up. Would you expect, and let's make this a little bigger, it's going to move to the left. Keep your eye on this point right here. It's going to move to the left, but by how much? Do you think it's going to move to the left by pi over 3? Let's see. Keeping your eye on this, it shifted to here. What does that say? Negative pi over 6. This is the corrected phase shift. This we're going to call the C term, okay? Pi over 3. But the phase shift is to the left, meaning minus pi over 6. Mathematically, how do we get there if you don't have the benefit of Desmos? You are going to do the inverse of the coefficient on x. So if it's multiplying by 2, you're going to divide by 2. This you're also going to divide by 2, okay, which is the same as multiplying by a half. So pi over 3 times 1 over 2 is pi over 6. This is the phase shift, and the direction will be the opposite of this sign, which is why it's left, which is why it's negative. Let's take a look at another one. I made this amplified by 2 so you can see it bigger. This is a short frequency, 1 over 3, a slow frequency, and that is why this sine cycle goes from 0 to 6 pi. It's long. It's triple the size, okay? But check this out. If you have a C of, in this case also, positive 2 pi, where do you think the beginning of the cycle is going to go? Would you expect it to go to here? Start to the left by 2 pi? Well, you kind of know that's not what it's going to do anymore, right? Let's apply the math and then pinpoint where it's going to go. Okay? If you take the inverse of this coefficient, meaning it's 3, you're multiplying by 3, you take that and apply it to this, 2 pi times 3 is 6 pi. And which direction is it going to move? To the left, negative 6 pi. This cycle should start way to the left of its original starting point. Okay, so let's take a look. Does it go all the way to negative 6 pi? And you know what? What's interesting is that it overlaps the original function. You don't see any change between purple and orange, but I can assure you that the cycle did shift all the way to here, negative 6 pi. Now you could be asking, hey, why didn't it shift to here? Well, this is not the start of the function, because notice if it started here, why is it going down? This has not been reflected. So the real new starting point is right here. It just happens to overlap perfectly with the original function. So to recap, if you have a function with a c, such as sine, let's say, a frequency and a c, let's say, let's try 3x plus, I don't know, 2 pi, okay? And the c is what I'm calling this. This is not the phase shift, because the shift happens when you apply, when you do the math. You divide by 3, and that's because the frequency is 1/3, and you apply that frequency to here, meaning 2 pi times 1/3 equals 2 pi over 3. That is the phase shift. That is how much the graph will actually shift. In which direction? The opposite direction. Okay, and so when you throw in an x here, this is what will go at the top of your transformation table on the x side. I realize I think I just misspoke. This is not the frequency. This is, I don't know if I find a word for it. This is the frequency, but this is, I guess, the inverse of the frequency.